Yes, hello everyone. My name is Ainavena Solomon Spencer. I'm a student at Makerere University doing software engineering. Yeah, welcome you all to my channel. Please subscribe so that you can be able to get all the details on all the content that I post. So today let me just share my screen. Today I'll be learning about. Today we shall be talking about. Today we shall be talking about security in homes using artificial intelligence. It's a PowerPoint presentation. As you can see, home security can be a huge problem when it comes to the societies we live in, public lives and property. That's because of poor security. So, with this problem solved, the people in a given community and households can have a peace of mind, as access to their homes is limited only those whose faces are registered and for the people that they know. Okay, so application of artificial intelligence and security. So here I'm looking at the various ways when it comes to the field of security, but this main video is going to be focusing on facial recognition, artificial intelligence. So what is facial recognition? Facial recognition is one of the front runner applications of artificial intelligence. It is one of the advanced forms of biometric authentication capable of identifying and verifying a person using facial features in an image or a video from the database. Yes, so what do I mean here? The that is it is AI, the facial recognition AI is capable of identifying your face. So in case I put a hand, it won't be able to access my face. But and verifying, what do I mean by verifying? That it will have to first confirm whether you are a member of a part of the family or you're not by checking with the records that it has in its database. Yes. So therefore, with facial recognition set as the security measure, at the gates of homes and the entrance of front doors, access is limited to only those whose images are stored in the facial recognition database. That makes sense. So the type of data to be used. So basically, facial AI uses images. Yeah, it is these images. In most cases, this slide basically talks about how we can be able to store these images. So, and I I recommend use of OpenCV. OpenCV it has libraries like PyTorch and TensorFlow. Some of those libraries can help you when you're building facial recognition AI. Yes, I think in my next video I'll be talking about this. This one, so it's going to be a very short video, just talking about the introduction. So, yes, so as you can see that in most cases I prefer using the black and white images because with black and white, the camera, the facial recognition AI doesn't really have to do a lot because basically the image is in black and white. But when it comes to these colored images, you find that the tone of the skin, the pixels, the images being swapped with they a little bit worried. So at times access can be denied, yet the person is actually in the system. So the front camera uh, and the sensor, they also help when storing images. So as a person is approaching towards the facial recognition AI, it is able to what? It is able to take a picture or the sensor with and the camera work together so to take a picture, and this picture is either stored in the database of under the category of those people that are not allowed access to, or those that are allowed access to. And furthermore, you can even connect your phone. For example, if you're the household head, you can connect your phone to the facial recognition AI such that in case whoever is trying to approach your home, you can get a notification, or you can really see that so and so tried approaching my home, and you can either know that the person is a threat or is part of your family. Yes. So in case the image doesn't match any image in the database, access is not allowed. Of course, that is self-explanatory. That if at all we don't have, you're not allowed access into the home. If at all your image is not matching any in the database under the category of those people that are to be allowed access to, you're not allowed. you're not given access. So facial recognition AI uses both supervised learning and unsupervised learning. And we're going to see this. Okay, maybe let me first talk about both supervised and unsupervised. So, okay, so what is supervised and unsupervised learning? Unsupervised learning is the training of data models of raw and unlabeled training data. It is often used to identify patterns and trends in raw data sets. So, or to cluster similar data into a specific number of groups. So, what am I talking about? What does supervised learning, unsupervised learning? So that basically here, a human being, like human oversight is really not needed. That images, for example, images are just provided, and then the AI itself groups these images according to those that according to you will find that it has grouped these all these images based on a characteristic. For example, maybe all these guys are white or something like that. Yeah, so all these people are in the age between this and this, something like that. Okay, it groups them as the AI, like no human intervention is really needed. But then when it comes to the supervised learning, requires labeled input and output data during the training phase of the machine learning lifecycle. So the training data is often labeled by a data scientist or, for example, a labeler. So, so basically that is it. That here for this case, supervised learning, we see that a person guides and teaches the AI that no, so and so belongs to this class, so and so belongs to this class. So group so and so into this category. Yes, like human intervention is needed. Human effort is also needed with supervised learning. Yeah. So back to our PowerPoint presentation. Shall be looking at. Shall be looking at. So these are some of the differences with supervised learning, machine learning. Is trained on labeled data sets, while unsupervised machine learning, so the algorithm is given raw and unlabeled data sets, just like we've been talking about. So the problem of the model is depleted. So you find that supervised learning is generally used to classify data or make predictions. In supervised learning, you can be able to make predictions, predict the future, because you're having, first of all, data from a human, and you can, the AI uses this data to either predict the outcome or the next, for example, in case, okay, basically that is it. It is just basic knowledge. So supervised machine learning is much more resource intensive because the need of labeled data, while unsupervised learning is less resource. Okay, here we are looking at the data. Remember, we said that supervised learning, it requires labeled data, unlike the unsupervised learning. So that's what we're trying to make by resource intensive. So in supervised machine learning, you find that it can be easy to approach to reach the adequate levels of explainability because of the human oversight involved, while unsupervised learning, it is difficult to reach the adequate levels of explainability. That with supervised learning, you can, since there is human effort, you can be able to explain like the data, but no, for the fact that unsupervised learning uh, doesn't have any human effort involved or intervention involved, you find that it's hard to explain the data itself because the AI just groups the data according to to groups that even you yourself doesn't know. So supervised learning, these are some of the techniques in facial recognition, feeding maybe images, and for example, all the people that are to be granted access can physically register their faces by looking at the camera. Yes. So for unsupervised learning techniques, negative matrix factorization and principal component analysis are to be taken, are to be considered when we look at unsupervised learning techniques. Please, you can find more of this content. You can read more about these two on YouTube. You will get a clear understanding of really what I mean by this. So when it comes to AI technical challenges, we have the miscategorization of people, as I said, you find that there are two classes. So you find that maybe, let's say, I personally I am registered, and then when I go to the AI, it has it allows me, it grants me access, and then my brother also comes, just because we a little kind of look alike. He's also allowed, but he's also given access into the home. That is really not so good, because you find that you have a lot of people that can be able to access your home. So that is one of the technical challenge that facial recognition faces. Then maybe you can also look at various, for example, I register my face and it's actually not registered, or maybe placed in a different category than what I expected. Yes, so you find that what you expect is actually not what is happening. Yeah. So come to more of the technical challenges. We have the facial recognition, anchoring, and stability biases. Whereby these anchoring biases, just let me just share something small talking about that. So with biases, you find that these are some of the biases that we have. This is you can just copy it on this website, and you can read more about the anchoring biases, availability biases. But what I can talk about anchoring bias is whereby you find that the machine is actually taking long. You find that the machine is taking long to learn, and like the changes are really not made there. Then for the stability bias, I can talk about you find that the AI has deliberately refused to to add any new faces or something like that. And the only way is to first trash the whole thing and repeat the whole thing once again. Yes. So that is it. Then algorithms of new situations. So you find that new situations at times can be we find that registering a new face, image, or something like that is also kind of a challenge to the facial recognition AI. Yeah, so this brings me to solutions. There's some of the solutions. We can monitor classes, feed and teach the recognition. Yes, and we can monitor the new faces that are to ensure that it's actually being added. So differences between accuracy, recall, and precision reference score. Here, let me just talk about something very small here before we proceed. Here, so this is a website, blog.xleo something.com. Yeah, please read about these things. These things are easier here. They teach you about the true positives, true negatives, false positives, and false negatives, and how each and everything is applied when it comes to the accuracy, when it comes to the precision, when it comes to the recall and F1 score. Yes, trust me, these things are just so simple and basic. And in my next video, I'll be talking more about these things and actually applying them, especially when we dive into the code. Because in my next video, I'm planning to make a video about these things. Yes, so basically these are some of the differences between those two. So just like here, it says workspace false positives and false negatives have similar. That is when accuracy workspace. But if the two are different, it's better you look at precision and recall. And in this case, that is the F1 score. So evaluation metrics, these are precision metric, accuracy metric, and performance metrics. All these are just more of the things that these are evaluation metrics when it comes to facial recognition AI. You find that the precision metric, number of true positives, which are really positive. Just like I said, when you look at the website that I've given you, it will guide you more and you will learn more about these things. Because there's no one going to explain all these things like right now because of the time. Yeah, see you.